Right. In our previous presentation, we said we're now going to try to compute or determine inverse of a matrix. Right. We're going to start simple here. Now I'm going to start with what matrix of 2 by 2. But what you mustn't lose sight of is that if we've got a matrix of any order A, and this matrix has got an inverse, one condition which must be satisfied for a matrix to have an inverse, in other words, for A to power minus 1 to exist, determinant of A must never be equal to 0. That's more. You will see it why. As you discuss it, you will see why the determinant must never be equal to 0. Then, now once we've got an inverse of a matrix, we must know that this is true. You can commute these two, matrix and its inverse, and you multiply them, you get an identity of the type of matrix you are dealing with. And again, we can't lose sight of this now here. We're talking about square matrices. Are we together? Okay. So when you're talking about there are some topics when you're talking about topic organization in a web, there are things that must be immediately at your fingertips. When I'm talking about inverse of matrix, you must immediately at your fingertips. It must be a square. Determinant must not be 0. All those things must just fall in place. Is that right? Then those are things you're going to guide you how to work. Are we together? Okay. So let me start small here. I will start with a really kind of more or less general thing, and say that I've got A, I've got B, I've got C, I've got D, and let's say this is an inverse. No, say this is a matrix. And then I suppose that this matrix has got an inverse which is X, Y, U, V, and Z. This is a claim I'm making. This is a claim. I'm making a claim that this matrix is an inverse of that one. But once I make a claim that notation there, inverse. Once I've made that a claim, I'm expecting this to happen. Who can tell me why? Why? Because this is what this line is saying. This line is saying, whenever you multiply a matrix by its inverse, you must get an identity matrix. Are we together? Are we all on the same page? Okay. So then, let's do this. Let's do this. But if I multiply this way, it means I'm taking A, B, I'm taking A, B, C, D, and I'm saying I'm multiplying by. Can you allow me to change something here? This condition thing. Allow me to change something here. Right. I want to say X, Y, and then say U, V. All together. Okay. Then they say X, Y, U, V. Those are just variables. They're just holding a place for something, is it? So there's not a problem there. So now let's multiply. If we multiply there, we're going to say ax plus by, and then say cx plus dy. That's what I get from the first column. In the second column, I'm going to use AU plus BV, and here CU plus GV. Then I've got that. Are we together? Okay. Now, let's now see what are we getting here. What are we getting here? Because this is equal to this. Let me write it here and say this multiplication is equal to 1, 0, 0, 1. But what is that telling us? It's telling us that AX plus BY is equals to 1. Are we together? Maybe I'm doing something here which I didn't mention before, and it's coming out naturally. When I'm going to say two matrices like this are equal, I think it's to compare the positions, isn't it? Say this is equal to that position, this is equal to that position, this is equal to that position, this is equal to that position. So when the corresponding entries are equal, we say the two matrices are equal. Are we together? So okay, so that it makes sense to say this is equal to 1. But on the other hand, say cx plus dy is equal to 0. Let's have this a system of equations. On the other side, on the other hand, we've got the AU plus BV equals, you can tell me, 0. The guy who says 1, he is still going to open his eyes. Don't worry about it. Then there's CU plus BV equals to 1. The guy who said 1 now is correct. That's another. So our unknown is the inverse. Our known is the matrices given APC, isn't it? So now it will be interesting to know X, U, Y, and the V. Then we know the inverse. But now, where are we going to know that from? We're going to know that from this system of equations. Are we together? Okay. Let me do this. Let me see if I can pick this. No. Let me do this first. What we keep in our mind is that A by inverse equals to A inverse by A equals to identity. Now let me pick this now. Right, let's do this now. Let's find the X and Y using Cramer's rule. Indeed, we know Cramer's rule from yesterday, isn't it? Did you talk about Cramer's rule yesterday? No. No, okay, let's forget about that. We're going to talk about that later. I'm just surprised why you didn't use Cramer's rule in your group yesterday. But okay, it's fine. But anyway, let's solve it using the method of elimination. We did the method of elimination, is it? Okay. I thought you were also going to say no. So it's a x plus by equals to 1, then c x plus dy equals to 0. Then our method of elimination, let's say we multiply, just check this, we multiply equation 1 by c, and we multiply equation 2 by minus a, then we add them together. All together. So what we're going to have here, we're going to have ax plus by equals to 1. Then in the second equation, this is what we're going to do. We're going to multiply this by c and this by minus a. We add them together, we're going to get 0 here. Do you agree? That's C. We're going to have AC here and the minus AC here. You add them together, we're going to get 0 here. Do you see or don't see? Guys, what is A times C? It's AC. What is minus A times C? It's minus AC. Add them, you get 0. You are too slow. You know what we're going? You want to see 2 multiplying 3, and you want to see 3 multiplying 6, then it makes sense. No. This is the any number, C. This is any number, A. This is any number, A, so minus A is there. So multiply this by minus A, multiply that, so you get 2 numbers there with opposite signs. You add them, you get 0. Are we there? Yes. Okay. Now let's come here. You multiply this one by C, you get BC. You multiply this one by what? By minus A, you get minus AD. You add them together, you get BC minus AD in brackets X. Do you agree? So we're going to get here plus BC minus AD brackets X equals to what? Come again? Or Y, sorry. Why don't you just say it's Y? I mean, just say, no, there is Y. Now you ask me questions like, where does it come from? It sounds like interrogation. It's Y, isn't it? Equals to, do the same multiplication. Thereby, C, thereby, A. There is 0, so I'm just going to get the C. Then, let's move our line here a bit to there. Now, if you want to get Y here now, what are you going to get? You're going to divide both sides by this coefficient, isn't it? So get C divided by BC minus AD. All together. Okay. Then I just want to see where I can store this thing. Let me remove this. I will rewrite this thing there and say Y is equal to what? C over BC minus AD. All together. Okay. Then let's leave it there. Let's come back to the same equation here. Let's come back to the system equation. I want to now I want to eliminate Y. You understand? I want to eliminate Y so I can get X. So check what I'm going to do. I'm going to multiply this by by D. Because my aim is to make the coefficients, I'm going to multiply this by B and this by minus B. So here, I'm going to have BD, here minus BD. I add them, I'll get 0 here. Do you agree? Then here I'm going to have D minus 0B. Then I get here D. Then what I'm going to get here? I'm going to get AD. How together? AD minus BC. In brackets, X, not Y. Conclusion, X equals to D over AD minus BC. All together. How can we write the 2 with the I like this denominator. I'll show you, you'll see why I like it. I like this denominator. How can we achieve the same denominator there? How can we achieve the same denominator there? I'll tell you. You multiply the numerator by minus, the denominator by minus. Do you see? So if I multiply that denominator by minus, the numerator by minus, I'll get the same denominator. Do you agree, guys? Okay. So we're going to have here AD minus BC. I'm done with that one. Now let's move on. What are we left with now? What do we need to find out now? We need to find out V and U, isn't it? Because remember the inverse was made of X, Y, V and U. Do you agree? So right, now we need V and U. You come exactly with the same thing. Let me draw my line there. Then I've got A, U plus B, V equals what? 0. Then I get here C, U plus D, V equals to 1. I want to eliminate U. I'll multiply here by A and here by by C here, by minus A there. Then I'm going to get a 0 here. Then when I come to this one, what am I going to get? I'm going to get BC minus what? Minus AD. What is that? That's V equals to minus A. Do you agree with me? Okay. Then at the end of the day, voila, V equals minus A over BC. BC minus AD equals A minus AD. It's getting me problems there. Let's say minus A. It's really conflicting me now. AD minus BC. What am I doing? I'm trying to achieve that denominator. Do you see? Okay. Then let's maybe pick this thing. Let's pick this thing and say let's move it there. All together. We can see it. Isn't it? This is V. Okay. 5 minutes more. Okay. Let's come in quickly and eliminate the other one. Let's get rid of this. Now we want an equation now with what? This was V. We want U, isn't it? So what are we going to do now? We multiply this by. We're eliminating V, né? We'll multiply this by D and multiply this one by minus B. Then This is going to give us 0 here. What are we going to get this side? We're going to get AD minus BC brackets equals to, no, sorry. What do we have there? U of it. U equals, what are we going to get this side? Minus B. All together. Then what's going to happen now? We're going to have U equals to minus B over AD minus BC. Now, we can now make the matrix which you call the inverse. It was XY, remember? It was XY, which means it is what? D. Okay, let me do this now. No, I don't want to stay. I want to check with you something. Do you see that we've got a common factor 1 over AD minus BC on all the factors? Let me take it out. Like remember I said, we can multiply matrices by number. So let's take that number out. Then inside what I'm going to left it. Where there was X, which is D over that number, we're going to have D only. Where there is Y, where there is that number, we're just going to have minus C only. Where there was U, here, is it UV? What are we going to have? Minus B, and then A. Then I ask a question. What is the determinant of A? According to what we did yesterday. AD minus BC. Check this. This is say 1 over the determinant of A. This is what is here. Altogether, multiplied by something there, which is D minus E minus C and A. And that is the inverse. Because of time, what I'm going to do now, let's leave it there. We're going to take it from there. But I want to invite you, go back home and try to take this matrix as it is, multiplied by the matrix A, and see if you cannot get identity. I'm sure if you do it very well, you're going to get an identity. So what we're going to follow now, well, I'm going to unpack for you what is the meaning of this, how to get to this. Then from there on, you have got a method of finding the inverse of a 2 by 2 matrix. Then later, we'll see what to do with the matrices of a higher order, higher than 2. Thank you for listening. Good luck for the rest of the day.